Now, this to-do list app that we're going to look at, I built this from scratch. I didn't copy this from some other to-do type of tutorial or something like that. I sat down and thought to myself, what are the key things that I would want to talk about in an hour and a half to 2 hours on this so that other developers could get up and running? And then I started with that and then built out these 6 parts to the demo. The 6 parts, I have the descriptions listed here. The first step is just getting some starter code so that we can actually see a list of to-dos. I'm going to show you how to set up an in-memory to-dos data source. Then we're going to take a look at implementing a new to-do form. What would you do on the client side and the server side for that? We're going to add the ability to mark the to-do complete, the ability to delete the to-do, and implement better error handling. Each part along the way, we're going to encounter little technical challenges that we're going to have to work through, either on the HTMX side or on the Rust Actix Web side. And so we'll highlight those as we're looking at the code. But with this basic application, you can start building real things using in-memory data. I'm considering doing a second part to this course where we do a database as our backend and implement some things like user login and sessions and stuff like that. I have a bunch of code already written around that. And so if you're interested in us doing a part 2 to this, when I give out the survey link at the end, make sure you mention that on the survey. Hey, I'd love to see a part 2 on this, where we do a database and sessions and logging in. And maybe that'll be one of the things we schedule for the fall. Okay, with that said, let's go ahead and take a look at these other examples. Now, for these examples, I decided to go ahead and code them ahead of time. You've seen how the whole thing comes together now. Well, let's take a look at some prepared code and walk through these here for the next 45 minutes or so. So let's start off first with our part 1. And you'll see here inside of our static folder, I have an index.html file. I also have a style sheet. So the style sheet is going to be the same as we go through the various parts. All it basically does is add a little bit of styling to the page to make it look a little bit nicer than just no styling. And we're going to be adding to the HTML file here various HTML parts and pieces as we build out the functionality, which ties back directly into the style sheet. So you'll notice here in the body, I have this H1 element that says to-do app. I have a little div tag with class container that's just to do some styling and stuff like that. And then I've got this unordered list. The unordered list, you'll notice, has some of those special HX attributes. The HX attributes, when you see that, that's referring to HTMX. And you'll see that we're going to add the ability to make that call back to the server directly on the unordered list. So remember, most HTML elements don't have the ability to call back to the server. There's a few exceptions. An anchor tag can call back to the server. A form tag can call back to the server. But most tags don't have that ability. But HTMX, through the HX get attribute, is going to enable me to do that. The question, though, is what triggers this get request to occur? Well, obviously with the button, if you click the button, that triggers the HX get. But what would trigger that on an unordered list, right? The unordered list is just semantically identifying this HTML content as an unordered list. It doesn't have any other functionality beyond that, not like a button, which is something you typically can click. We're going to use another attribute called HX trigger, and we're going to identify the event that's going to run that's actually going to make that call. So when the unordered list is loaded up, then it's going to call to the backend to get the list of to-dos that we're going to display inside of it. Now, you'll notice I did not specify the HX swap. So if you remember back over here in our Hello World app, we had this HX swap. The HX swap defines what it is you want to swap. In this case, we swapped out the outer HTML, which means I replaced the entire button. Well, here, I didn't specify the HX swap. So what's going to be swapped out? Well, the default is inner HTML. So when I get back my list of to-dos, I'm not swapping out the entire unordered list. Instead, I'm swapping out the content or the list items of the unordered list. Okay. The reason why I need to know that is over here when I go to implement my routes here, okay, I'm going to have to decide what type of data I'm going to be sending back. Well, I'm going to be sending back my string of list items, not a string of an unordered list and list items, but a string of the list items. Okay. So now that I'm going to return back my string of list items, that's what's going to be populated here inside of the unordered list. Let's run this code, and then we'll go back and take a look at the Rust side and see what Rust is doing for us to provide that list. So if I come into here and do Control C, and we'll go to do list app part 1, and I'll say cargo run. We'll come back over here and reload. So there's a little bit of styling, and there's the to-do list items that I'm getting back. Now, if I refresh this, let me get rid of preserve log. If I refresh this, you'll see there's the download of the HTML, the CSS, HTMX, and there's the list of list items that I'm getting back. Okay. So remember, what you're swapping on the client side influences what you return on the server side. But you can see that request is being made there. So coming back over to here, let's take a look at what we're returning back. Going to, hold on one second. Let me close that. Okay. So we have this new to-dos routes. We have a little struct here with a task string. We have this to-dos list. This is the URL path that we're going to be handling that GET request on. Creating a simple vector here of to-dos, and it's complaining about something. It doesn't want me to use a vector, it just wants me to use an array. So there we go. And the reason why Clippy is telling me that is because we're not really modifying the vector at all. So just making it a simple array is all we need. That's one of the cool things about Rust, right? Rust does a great job in, especially Clippy, does a great job in analyzing our code and letting us know what we really need versus what we don't need. All right, so we've got our array of to-dos here. Now inside of here, I'm going to take that array of to-dos. I'm going to iterate over it. I'm going to take each to-do and build a list item. I'm going to collect those list items together, and then I'm going to return them back. Joining it with a new line isn't necessary, but if you want to have something that's easy to kind of look at and see in the response that comes back if you're using the browser developer tools, then having that new line makes that a little easier to read, I suppose. Anyways, really what we're doing here is we're just taking whatever our data structure is in Rust and basically transforming that into an HTML string for whatever the data is that I want to return. So in this case here, I'm going to take that to-do list HTML and return this back. Now, when I was first working with HTMX, I kept thinking to myself, I need to return JSON like you would in a traditional React or Angular app, right? I had to keep reminding myself, wait a second, I'm not returning a bunch of JSON for my array of tasks. I'm building actual list items, and then those list items are going to be populated inside of here. I know it sounds simple enough, but if you've done a tremendous amount of client-side web programming and you always think of calling the server as JSON, you'll be surprised how much you kind of trip over yourself trying to remember that you're not returning JSON, you're returning back these HTML snippets. So over here in the main file, I've got the to-do list registered as a service. And that's pretty much it for the little hello world of our to-do list. Nothing too exciting. All we really did was incorporate some data and write some code to dynamically generate this HTML. Okay, let's take a look at the second part. So in the second part here, we wanted to set up an in-memory to-dos data source. As you can imagine, putting the actual to-dos struct, hard coding this list inside of our endpoint, that's not really what we want to do, right? So we need to kind of restructure our data a little bit here. So what I'm going to do is come into part 2, and I'm going to add a models file. So I'm going to move that to-do struct out to this file. I'm also going to mark it as being able to be cloned. Okay, so what you're going to find is when we start to work with setting up a data source, we're going to need the ability to do some cloning. And so my struct that I've created here needs to be configured so that I can clone it. So we're going to do derive clone. In our to-do routes, you'll notice that I'm no longer initializing the data. In fact, I'm going to be receiving the to-dos through this function parameter. So what's going to ultimately happen is over here in the main RS file, we're going to create our vector of to-dos, and we're going to wrap this in a web data structure. That web data structure is going to be registered with app data, and it's going to be automatically passed into our endpoint when we request it. So here I'm requesting the to-dos. It's going to take the data that I've configured here, and it's going to pass it in, and then I'm going to be able to work with it. Now, this is where we start to enter into the world of concurrent programming and memory safety. If you look at the original example we had in to-do list app part 1, you'll notice that when this endpoint was called, it created its own list and used its own list to generate the output. So this function, this variable, owned this data. So there's nothing exciting happening here. But what happens in part 2 when I start passing in my data like this? We have a little bit of a memory safe programming issue, don't we? Imagine a real application up and running with hundreds of users making requests into the application. Well, each of these users are going to be calling in, and we're going to be handling those requests concurrently. I want to share this data across those different concurrent requests. Now, in a language like C# or Java or Python, this would not be something that we would even think about. We would just have our data up on the heap, and then any of the threads, or if we're doing asynchronous programming, any of that would be able to access that data on the heap and just utilize it with no problems, especially if it's just reading the data. Over here, though, this is Rust. And so now we have to start diving into dealing with who owns the memory, who's borrowing the memory, who's just reading it, who's allowed to write to it. Fortunately, in this example, we haven't started writing yet, so we don't have to deal with that complexity. But we still have to deal with the complexity of this data being made available to all of these concurrent requests. In order for this data to be made available the way that we have it set up here, we have to be able to clone the data. So essentially, when I took to-dos and I said to-dos.clone, vectors out of the box can be cloned. But I had to modify the to-do struct so that it could also be cloned. So the reason for the cloning is so that we can clone that list across these different requests that we're receiving. And so that's where we start to get into the whole memory management nature of working with Rust. Now, this part here, just calling .clone, isn't a big deal. Where it becomes more complicated is once we get into having to modify that list. That's when we're going to have to break out things like the arc and the read-write lock so that we can have multiple readers, but just one writer, but be able to share that across the different concurrent executions through the use of the arc type. We'll take a look at that in the next little demonstration. So coming here into part 3, let's take a look at how we can go about adding a to-do to the list. So first of all, let's start here with our HTML file. We've had to add some new HTML to be able to collect the data on the list, and then also make use of some new HTMX attributes to communicate that data back to the server. Now what I'm going to do is I'm going to put these on multiple lines here. My code reformatter likes to spread it out, but let's put it on multiple lines there so we can make this a little easier to read. So first of all, we've added a form above the list. The reason I've added it above the list is so that as we're typing into the form and adding items to it, the form doesn't get continually bumped down on the page. You'll notice we have a new HTMX attribute here called hxPost. Okay, hxPost is going to make that post request up to the server and save our data on the server. hxTrigger tells it what event is going to execute to trigger the post. I've explicitly said hxTrigger submit. I can probably leave that off because the default event for the form is going to be submit. Just like on the button, you could have put hxTrigger click, but the click is the default event for the button. Also, I've listed the hxSwap. I don't really have to list it though because the default is inner HTML, but I can list it here explicitly. The part that's going to be different is this hxTarget. We don't always want to replace the element that launches the request. Sometimes one element launches the request and another element actually receives the new content to be swapped out. In this case, I'm going to submit the form, but I want to update the list. So you'll see here my hxTarget is now going to be targeting this list. It's going to swap the inner HTML when I submit the form, and it's going to swap it with the content that comes back from here. Now, once you learn what these HTMX attributes are, look at how declarative and easy to understand that is. It's very clean. Even though I have a couple of extra attributes I can probably omit, it's very clean. It's very easy to understand. I'm not having to write a lot of JavaScript code. Remember, in the course of programming, We always start off with very imperative technologies where we have to decide what we want to do and we write all the code for all the steps. But as programming technology develops, as software develops, we move from imperative structures to declarative structures. Declarative structures are where you describe what you want, but you allow the runtime to handle the details for you. Here, we're letting the HTMX runtime handle the execution of the code and the actual code that makes the magic happen. It's providing to us a very declarative structure, though, to work with to describe what we want to have happen. Declarative structures, in many ways, can be easier to understand. Of course, it means you have to learn the declarative API, and sometimes declarative structures can be limiting. But for very common operations, this is much easier to work with than having to write a bunch of JavaScript code yourself. We can also connect into other types of events that occur. As you know, in the DOM tree, there are the standard web browser DOM events, but HTMX also adds to the mix its own custom events like this after request. And what this is going to do is, after the request has completed, we're going to empty out the form, so the form is blank again. Down here, I have a button. When I click the button or hit enter inside the input field, it will trigger the submit event on the form. That submit event is built into the browser. Now, when I submit that, I want to accomplish two things. I want to take the task and add it to the list of tasks. I also want to update the list in the web page. So my endpoint here is going to do two things. It's going to both add to the vector, but it's also going to refresh the list. Let's take a look at how we're going to do this. First of all, I'm going to need to bring in Serde because I'm going to need to be able to do serialization. When I capture the to-do data in the browser, in the form, I need to serialize that and then be able to deserialize that on the Rust side. So we're going to bring in Serde and do our deserialization there. Next thing we're going to do. We're going to create a tools data struct that's going to represent like a data service in the application. So to-do is the struct that holds individual to-dos, but I'm going to need additional functionality to actually manage that vector of to-dos. For example, the ability to initialize a new vector, the ability to add to the vector, the ability to iterate over the vector. So these methods are going to give me that common functionality that I'll need to do with this to-do data service. In my main, I'm going to create my new to-dos data service, and I'm going to populate that data service with some initial to-dos. Here's the thing, though. The new functionality that we're adding is the ability to add to-dos to the list. What do you notice about this right here? I'm going to need a mutable reference. Why? I'm going to be mutating the vector. If I'm going to mutate the vector, I need a mutable reference. If I need a mutable reference, that means I'm writing to the list. I'm not just reading, I'm actually modifying it. And that's where things are going to get complex with Rust. What I'm going to need to do is take my data service and wrap it up inside of an RW lock and wrap it up inside of an arc. Typically, when you see the arc being used, you'll see people either using a mutex or using RW lock. What's the difference? With the mutex, you get exclusive access for reading or writing. That's good, but if anything else needs that data, it has to wait until that mutual or until that exclusive access has been released. Well, here's the thing. Exclusive access is great if you're modifying the data. But in a web application where you have lots of requests coming in, exclusive access for one request for reading the data doesn't make sense and will result in performance bottlenecks. So what I really want is this. If all we're doing is reading, I want to allow multiple readers. However, if we're writing, then I need that exclusive lock while we're writing. And then once we're done writing, we can release that exclusive lock. Okay? So we're going to use the RW lock to accomplish that. Well, that's great. That handles the locking. But now we have a second problem. We need to be able to have some type of multiple ownership through the use of reference counting. But because we're going to be doing this concurrently, we have to use the atomic reference counter to wrap up our structure here. So we have our arc and our RW lock. Down here, I'm going to have my tools data be configured with this type, and then I'm going to wrap it up here in the web data and register it. So I'm still using the web data here to share the data across my endpoints, but I'm going to be using the data wrapped up in this arc RW lock. So how does that change the actual route code that we're working with? In the route code, we're still going to be receiving this data like we did before. But now what's going to happen is we're going to have to get a read lock, although there can be multiple read locks, right? If we have multiple people, multiple requests needing access to the data, we're still going to have to get a read lock, and then we can work with the data. If I need to write to it, I'll need to get to the write lock, and then I can start modifying the data. However, there can only be one write lock at a time. And when we have the write lock, there can be no read locks. So essentially, when you say write, it's going to wait till all the existing read locks release, and then we'll be able to write to the data. So here we have an example of the write. Now you'll notice I've got some unwraps in here. As we all know, unwraps should never be really in, unwraps in this kind of type of context should never be in production code. Part 6 of our demo, we're going to remove the unwraps and take a look at how to handle errors. Anyways, you can see where we're bringing in the arc here to be able to share this data across the different concurrent requests. This extra step that we had to do here is not something that you would do in those other web frameworks, in those other garbage collected languages. This is something where you're dealing with Rust. You'd have to handle it this way in Rust. If you're new to Rust or it just doesn't occur to you that these are going to be, lots of concurrent requests coming in, this is an area where one could get stuck in trying to implement this code. But once again, when you take a step back and just kind of think about it, you'll be like, oh, that's right. I have multiple requests coming in. I need to use my data types to safely share that memory across those concurrent requests. Now, before we move into part 4, 5, and 6, what I'm going to do is I'm going to go ahead and give you the link here to the survey. We've got about 45 minutes until our official end time, but I know some people may not be able to hang in till the end. So if you have to take off, no problem. We're going to be posting the recording up by the end of the weekend. You can go back and watch the part that you missed. But if you have any feedback you'd like to offer us, we would be honored if you took the time to do that. And don't forget, if you've got ideas for things, future topics and stuff like that for the fall, I am planning out the schedule now. I'd love to get your feedback on that. If you'd like a part 2 of this, where we bring in the database and logging in as a user and stuff like that, also would like to know that too. You can see about getting something like that scheduled as well. Okay, so now that we've got this ability to add, let's actually run it and confirm that it works. So I'll come into here and I'm going to stop this. And we'll say to do part 3, cargo run. We'll go ahead and come into here and refresh this. And you'll see now I'm getting my list here. I could type in cool, hit enter, and it's now added to my list. So you can see here in my add response, I've got the list of items. And then in my payload, it sent up URL encoded form data with the data to add to the list. If I refresh this, you'll see it stays in the list because while I'm refreshing the web page, the web server continues to run, and we're basically sharing that data service across all the requests. Now, let me come back over here real quick, and there's one thing I didn't mention that I want to mention before we move on, and that's this part right here. Remember how I told you we needed to be able to deserialize the to-do? So over here in models, we applied deserialize. As a parameter here, we can say web form, give it the struct that we want to deserialize, and it will actually translate the, excuse me, it'll translate the request that we make here with the URL encoded form data. It'll deserialize that into the to-do struct, which we can then make use of here inside of our code. You'll notice that this is really a form to-do. So to access the inner data, the actual to-do, we use the into inner function right here. And that gives us that inner value, which is actually the to-do. Okay, pretty cool, right? So now we have the ability to add. Let's take a look at the next demonstration, which is our ability to mark this complete. So what you're going to notice here is that nothing has really changed on our index side, except that I've added a hidden field for completed. The reason I've added a hidden field for completed is that our new model now has a completed field on it. And so in order to deserialize this form content into a to-do, I had to add this hidden field so it could deserialize it into this structure. Also, you'll notice I now have a new to-do and I have a regular to-do. The difference is the new to-do is just this to-do form, which is just the completed and the task. The to-do here has task and completed, but it also now has an ID. The ID is going to be useful because I can now use the ID to know which task to mark as completed, but also later on we're going to add the ability to remove a task, and I can remove that task via ID as well. Now, one thing I want to mention as we move into these last 3 demos, you're going to see that I've made some decisions about some details about how I have chosen to code this server-side code. In a larger application, I would probably make other choices about how to organize and structure the code for generating all of this HTML on the server. I've intentionally chosen a simple structure here for the demo so you can easily follow what's going on. But as you start to build this application out, just because we're not using JavaScript doesn't mean we don't have to write a lot of UI code. It's just we're writing that UI code now on the server. There is no component-based architecture that's like built into HTMX. So you really have a choice as to how you want to generate that HTML. I've chosen a relatively simple and straightforward way to do this, but as your application were to grow, you might choose to use server-side templating systems. You might choose to even create your own kind of server-side component-based type system. There's a lot of decisions you'd have to make on how you want to render this server-side code. When you look at my implementation, understand that it's designed to be simple so that it communicates the general concept of what we're trying to do. But in a real application, you'd want to do something a little bit probably better designed, more robust, so on and so forth. So let's take a look at what that server-side code now is going to look like. So on the data side, we're going to have a function here where we're going to mark these to-dos as completed using the to-do ID. It's really just doing toggling. So if it's not completed, it's now marked as completed. If it's not complete, if it is completed, it's marked as not completed. However, because I have introduced the ID and the completed fields, that has impacted the other code that I already had. For example, in the add to-do, I now need to calculate the ID of the to-do that I'm adding to the list. So essentially what I'm doing here is finding the max ID and adding 1. If I have no to-dos at all, the max ID is 0, and I add 1 to it. Down here in the toggling completed, I'm simply iterating over the to-dos. I'm getting a mutable iterator so that I can modify the to-do value to toggle it between completed and not completed. I'd like you to observe real quick. I didn't mention this earlier, but let me mention this now. I'd like you to observe how I keep my data service decoupled, the implementation details decoupled from my routing. I don't like to put my data management code inside the router. I want the router to be focused in on handling the requests, calling the data service. And then also you're going to see that I'm going to move the rendering of the list to its own function. So here you see the beginnings of where I'm refactoring the program now so that I have a method for rendering the list, and then my route functions call that method. So the route functions call the data service to get the data. It passes the data into this function. It generates the list. It almost starts to feel a little bit like an MVC kind of architecture where the routes are really my controllers. The data service is my model. And this is the rendering of my view. So I've done a lot of ASP.NET MVC and Flask and Express and stuff like that over the years. So you can see that MVC pattern just kind of naturally coming to light. The mechanism by which you do this rendering, this is where you might choose some type of server-side templating system or other technology to help you do that. For me, I'm just literally keeping it simple and just doing basic string manipulation or string transformation, whatever you want to call it. Now you'll notice here, my output for my list item is becoming more complicated. I'm now going to include a form for each list item. That form is going to have a hidden field for the to-do ID. It's going to have my checkbox, so on and so forth. For those of you who used to do a lot of server-side web development and then moved into things like React and Angular, you might have noticed that back in the server-side days, you used to have lots of hidden input types. But then when you moved into things like React and Angular, you didn't really use the hidden input type anymore. Well, when you come back into HTMX, the hidden input type is going to be useful for capturing things like the to-do ID and being able to incorporate them into a form submission so that down here, when we call toggle completed, it receives that form. I can get the ID and then do the desired operation. Now you'll notice something a little bit different here though. Up here, I had a specific struct type that I created for the new to-do. But what you're going to notice is down here, I went with a hash map. Instead of creating a special type to do that deserialization, I'm just going to deserialize directly into a hash map because all I'm really doing is passing up the to-do ID. But that to-do ID is inside of a form. It's a key value pair, so I need a way to extract that. And the hash map is a good way to deserialize and then ultimately pull out that value, which is what you see me doing right here. So anyways, that will then update the data accordingly. I then re-render the list and I send the updated list back. So for example, if we come into here and we go into part, part 4, and we run this. Now I can check the box, toggle completed. If I refresh, it stays completed. I uncheck it. Now it's not completed. A little bit of a typo there. Let's go back over to our code and fix that real quick. Up here in my HTML string, I think I've got an extra backtick there. Okay, cool. So there you go. So you can see how I'm building that HTML with the form and all that into each list item to make that call back to the server. Now, this is where you start to realize you're going to have your own complexities here with HTMX. HTMX is not how you avoid necessarily complexity. It's just you're avoiding complexity in JavaScript code. Here you're dealing with the complexity on the server side code. Okay, let's take a look at demo number 5 here, which is the ability to do the deleting of a to-do. This one's pretty straightforward, actually. We've already built most of the infrastructure that we're going to need. Essentially, what we're going to have to add is some type of delete button to each list item. So now I have a form here, and I have a form here. I have no problem with creating these individual forms. I've never noticed any performance issues by having lots of little forms. While I don't typically code that way in like React or Angular because we're doing everything so dynamically in JavaScript, I can, I don't even use the form tags abilities to do submitting to the server because I'm always using an AJAX call. In HTMX, because we're going to actually submit that form, it makes sense to have lots of little forms that capture the ID of the to-do that I want to toggle or captures the ID of the to-do that I want to remove. The only real downside that I see potentially with all of these little forms is that if you have a really, really, really big web page with lots and lots and lots of list items, it can add up quickly. Also, technically, HTMX is being applied to these forms when they get rendered. So there is a little bit of JavaScript and memory usage occurring there. So maybe for something really large, maybe this approach would have some drawbacks and limitations. But for what we're doing here, setting up these little forms and having the ability to easily capture the ID for what I want to toggle or the ID for what I want to delete works really, really well. Down here, I have a new method for removing. Same basic thing as the toggle for getting the ID. And then, of course, I had to implement a method on the data service that has the ability to do the removal. For that, I just used the retain method on the vector, passed it a closure, and then keep all of the to-dos that don't match the ID that I want to delete. This is similar to something you might do in JavaScript with like the array filter method. It filters, it keeps everything except for the thing that matches the ID that you want to delete. That's what retain is doing here for me. Okay. Let's just run that so you can see what it looks like. So we'll come into here and say cargo run. So now I can come in here and I can delete those. And there's our remove operating there. And there's our XHR requests. If I do preserve log, we should be able to see that when I click on this, there's no page reload occurring. Okay. All right. So let's take a look at our last demonstration, and then I have a couple of closing thoughts for you. If you could, don't forget to fill out that survey before you take off. It would be much appreciated. All right, let me go ahead and bring up the last one, which is going to talk about error handling. So as I was putting this all together, down here, we had the, oh, where's the one that I'm looking for? Let's look at this one. In here, actually, let's do the add. Okay. So if you remember in the add, we had the unwrap so that we could do the, so that we could get access to the to-dos data either with a read or write lock, so we could utilize it in satisfying the request that was made. In that code, we had an unwrap. The problem with the unwrap is that if it fails, it panics and kills the application. That's not what we want to have happen here. If a request to the server fails for any reason, we want to handle that. The challenge, though, with handling that is now we get into the result, enum, and the OK and error variants. And anyone who's done any Rust programming for any length of time knows that while result is awesome and treating errors as values is great, it does introduce additional complexities, especially when you have different result types, or you use something like anyhow, or if you want to use the question mark operator, everything starts to get a little bit harder to implement that code. So in a lot of example code you'll see online, you'll see where people use unwrap in the example, but that's just because they're keeping the example super simple. You would never use unwrap the way that you are using it there. You would never use that in real production code. So what would it look like to kind of upgrade this to actually handle errors correctly? So first of all, up here at the top, we have the result type that comes from Actix Web, and we can wrap our return type here, responder, we can wrap that in the result generic type. So now we have the ability to return errors, and we have the ability to return OK. So down here immediately, you can see where I'm going to start wrapping that HTTP response inside of OK. Now, one of the areas where we were doing the unwrap was getting a hold of that lock. And what I'm going to do here is, instead of saying unwrap, I'm going to replace it with the question mark operator. The question mark operator basically says, give me back the OK value, or if there's an error, then immediately return that error from the function. Okay. The problem, though, is the error that's going to be returned by getting the write lock is not going to align with the result that I have up here. So what I'm going to do is I'm going to use the map error function to basically say, hey, if I can't get a lock on this, let's return back an error that is compatible with this type. So essentially, I'm mapping from whatever error write would produce and mapping it to an error that's compatible up here. Up here, I'm going to say internal error new, failed to acquire write lock. I might want to replace that with some other piece of text if I don't want to be so specific. And then I'm going to return back my status code, which will be this internal server error. So now I'm handling my errors and not just saying unwrap and panicking. Remember, in a Rust program, generally speaking, you never want to panic in any of the functions that you call from main. Now, you might legitimately decide in the main function to panic, but when you're calling other functions, you don't want those functions panicking, especially if they're as part of a third-party library that other people are using that you've created. You don't want to be killing off people's programs and not giving them the ability to handle the error. When I teach my Rust classes, we basically establish the rule, once we learn how to do error handling, that you can only panic in the main function. No other panics should occur anywhere else, which of course then means properly handling result throughout your code. And there's a number of different ways to do it. We go over using anyhow, we go over the using the dynamic dispatch mechanism with the dyne keyword. We cover a variety of techniques one can use, remapping the errors, but you definitely don't want to be panicking. Anyways, we're going to handle that error. And what I've done for the purposes of demoing is I've set this up so that if we type in a task, make error, it'll give us back an error and we can see what that looks like. Now, how do we handle these errors over here in the HTML? Well, the first thing I did was I added a paragraph element to actually display an error message. But how do I populate that element when I need to? So let me just kind of put these on a couple of lines here. We had the same trigger submit in our HTML, same reset, but I've added this piece of code here. And this is just a little bit of JavaScript to do what I need to do here for handling the error. So when we make this request, if we get back a response error, we're going to run a little bit of code to update this paragraph tag with the fact that we had an error from adding the to-do. That's it. That's all we're going to do. We're simply just going to kind of blank that out. Now, if we successfully accomplish the updating of the to-do list, then we're going to blank out the error message and make it disappear. This is just one way of solving this problem. It's not the only way. I'm not even claiming it's the best way, but it's a way to incorporate error handling to the server side and then handling that error on the client side here in our HTMX configuration. So I'll come into here and I'm going to run this. And we'll say cargo run. And let's take a look at what it looks like to have an error occur. So I'll come into here and do make error, adding to do failed. Hit enter. And now my to-do list was updated and the error message is removed.